All right. So the reason why we call it analysis of variance is because the F value, whether we're talking about ANOVA or Levene's, the F value is always going to divide two variances. Okay, so it's the answer we get when we divide by, two variances, one by the other. So because variance is a squared number, remember, variance is always squared, that means F will always be positive. Because when we take a positive number and divide it by another positive number, the answer will always be positive. All right? A positive divided by a positive is always a positive. Okay, so F will always be positive. Remember that F has two numbers for degrees of freedom. Now, not only do we know that the first one is the degrees of freedom for the between groups source, and the second one is the degrees of freedom for the within group source, we now know that the first number is the degrees of freedom for the numerator. In other words, the number on top, right? If you divide one by another, this one is on top, or it's first. And then the degrees of freedom for the denominator, that's the degrees of freedom for what's on the bottom, or what comes second in the division. Don't worry, you're going to see this in action. How about now? Let's look at Levene's F value before we look at ANOVA's, okay, the single factor ANOVA. When you already know that we calculate Levene's F because we're trying to see whether or not the variance for group 1 is the same as the variance for group 2, or in the case that, now that we have 3 or more groups, we would just say Levene's F is going to see whether the variance for group 1 is the same as the variance for group 2, is the same for the variance for group 3, etc., etc. All right? So, in other words, we can now say that the Levene's F value is testing the assumption that all variances, all right, so for every group of your independent variable, all variances will be statistically equal. Okay, so whether you have 2, 3, 4, 5 variances, we want to test and make sure that all those variances are statistically the same. So what does Levene do? Well, Levene looks at however many variances you have. So if you have 4 groups, you're going to have 4 variances. And it finds the largest variance. So let's say group 3 happened to have the largest variance. Well, then we would put that on the top here. This would be the numerator. And then we're going to look for the variance that's the greatest, the highest variance. So if group 1 has, did I say the highest? The lowest variance, right? Gets my highs and lows mixed up here. So this is the greatest variance. So let's say group 3 has the highest variance. It goes here. And then we want to find the group with the lowest variance, the smallest variance. And let's say that happens to be group 1. Then that's fine. We take the highest variance and we divide by the lowest variance. So max minus mean. So it doesn't care which group has the highest variance and which group has the lowest. That's irrelevant. All it cares about is the numbers. So we're dividing the greatest variance by the smallest. All right. Now, going back up here, the F value is going to have the degrees of freedom for the numerator. And then you're going to have another degrees of freedom down here for the denominator. So that's why we have 2 degrees of freedom. One for the top, one for the bottom. And remember, which one is always going to be larger? It's the second one, the one on the bottom here, okay? Now, let's look at the case where, we have two groups. or 3 groups. Doesn't matter. However many groups we have. We're only comparing 2 variances here, right? The biggest and the smallest. And if those variances are approximately equal, then what should the F value equal? F will also be close to 1. What was this? If the 2 variances are about equal, then F that should be a B. B close to 1. All right? And not significant. All right? Because why? Well, think about your HO and HA. HO would say null, none, and nothing. Your variances are all the same. HA would say, wait a minute, you do have something more than just sampling error. Your variances are different for more reasons than just sampling error alone. Okay, so this is a case where, recall, we don't want Levene's F to be significant. All right, this is the case where we actually hope that we can retain HO. If we retain HO, we're saying that the variances are the same. And what we're going to do is, if we have just 2 groups, well, we can, easily look and see, okay, well, this group, it has the highest variance, it's going to go here. And this other group, there's only 2, the other one goes down here. But if we have, let's say, 4, 5, or 6 plus means, groups, if we have, 4 or more groups, 3 or more groups, in fact, then if we compare the highest variance to the lowest variance, that's going to give us the best test to see if the variances are all equal, all right? Because we would expect, right, that if you don't see a difference between the greatest variance and the smallest variance, well, you're not going to see it anywhere else, okay? All right, so we've learned here that with Levene's F, the formula is very simple. Just find the group with the highest variance, and that goes on top, the variance. And the smallest variance, the group with the smallest variance, goes on the bottom. Divide them. If these 2 variances are approximately equal, we're going to get an F that's very close to 1. And that means that, if we were to, actually, I'm going to take you back. I have to do this in little steps here, but let's go back. If we get an F value close to 1, like here's 1.029, these are all high probability events on HO, right? So if we get an F value close to 1, we are going to retain HO. We need to be out in the tails here, right? We need to be in a rejection zone before we can reject HO. So now resuming, again, I have to kind of do this in stages here. All right. So we're actually hoping that with Levene's test, we get an F value close to 1. It will not be significant. And what that is telling us is null, none, and nothing. In all probability, any difference between your variances is simply due to sampling error. If all else fails, remember the mnemonic. We never want our S's to be significant. Levene's test is a test of an assumption, right? Homogeneity of variance is the assumption, HOV, homogeneity of variance, and it's tested with F, and we don't want that to be significant.